Okay, welcome. Welcome, everyone. Thank you guys so much for coming. I am going to let the moderators tell you a little bit more about these panels, which are a great part of this program. I just want to tell you a little bit about ICERM. So ICERM is the Institute for Computational and Experimental Research Math. So the people that are here for this semester, they're all mathematicians, but they all also create wonderful art. Hopefully you've gotten a chance to see some of it. If you wander downstairs, there's also some other great stuff that you can, some of which you can touch and handle, and it's hopefully marked pretty well, which you can and which you can't. The only other thing that I want to say is please stay for a few minutes afterwards. There's going to be a small reception. So we're hoping that some conversations will get started during the, well, after the panel. Well, during the panel and then after as well.
Okay, so welcome. I'm one of the participants in the workshop. So this is the third of these panels, and well, we had the idea of just kind of getting together mathematicians and artists and just sort of see what would happen. I think sometimes people think of mathematics as being kind of, maybe from the outside it may look kind of logical or cold, calculating in a way, but there's all these kind of I'd say all these kind of beautiful images that are sort of invisible, that often guide people in the way they think. And one of the purposes of this program is to sort of bring these things to life. And so there's people from all over the world here who are experts at kind of producing these beautiful things, and that at least kind of verges on artwork. And so, you know, our artists also, you know, think about things like space and organization, geometry. And so we just thought these panels would be a way for people to explore common themes. So that's what it's about. The format is there's going to be about 20 or 25 minutes of presentation, and then please ask questions. That's what's coming. So I'm going to introduce the first two speakers, and then Allison will introduce the last two. So Werner Sun, he's the IT director at the Cornell Lab for accelerator-based science and education. He has his undergraduate and graduate degrees in physics, and he's trained as a particle physicist. So he's working things like the with particle accelerators. He also was a pianist in his youth, but then he's also an artist, and he makes these beautiful sort of kind of hybrids between sculpture and digital printing. He's had numerous shows around New England, and then especially in Ithaca, and he's the 2019 recipient of the CUE Artist Empowerment Grant. His work, his images and words have been in like magazines such as Stone Canoe and Brooklyn Rail, Sci Art. So there you go. Then there's David Dumas, whom I've known for quite a long time. He's a mathematician, got his PhD at Harvard. He's currently a professor at the University of Illinois at Chicago. He works in things like hyperbolic geometry, projective geometry, moduli spaces, Teichmuller theory, complex analysis. When he was a postdoc at Brown, and when he was here, he installed his own, like a kind of a jack into the car so he could listen to music from his iPad. And he's been soldering things since age 9. He has a kind of great facility with kind of electronics and also programming. He made a VR ping pong game. You can play ping pong in this thing with yourself in a 3-dimensional cube. Let's see. I mean, he's had a number of grants from the National Science Foundation, including an NSF career grant. Visiting Simons professor at MSRI. He was actually here in our program 5 years ago at ICERM. So there you go.
Hi there, I'm Allison. I memorized all this stuff like Rich, so I'm going to have to read some things. Third, Masha Ryskin, good friend, is a Russian-born printmaker, painter, and installation artist. A political refugee from the Soviet Union, she received a classical education in painting in the Soviet Union before earning a BFA in printmaking at Rhode Island School of Design and an MFA in painting mixed media at the University of Michigan. Her work has been exhibited both nationally and internationally and is really wonderful. Ryskin is also a recipient of numerous grants, including a Fulbright Fellowship to Oslo, Norway, and the Rhode Island State Council on the Arts Fellowship in Printmaking and Drawing. She has collaborated with a number of artists, including Margaret Yuko Kimura, printmaker from Cleveland, and most recently with Serge Marchetta, a mixed media artist from Montreal, and here as well. Together, Marchetta and Ryskin have exhibited in the United States, Canada, and Europe. Ryskin is currently Associate Professor at Rhode Island School of Design. And Serge, after 18 years of service in the Canadian Postal Service, Serge Marchetta quit in 1993 and began a new career as a visual artist. After graduating from the University of Quebec in Montreal in 1995, Marchetta began exhibiting work in numerous solo and group exhibitions in Montreal, province of Quebec, Europe, and the United States. Marchetta was also the curator of several important exhibitions and the director of the Galerie d'Art La Liberté in Montreal from 2004 to 2008. He's a grant recipient from the Fondation Thénault, France, the Ragdale Foundation, USA, and the Conseil des Arts et Lettres in Quebec. His works are included in both public and private collections. There you go. So mostly we just would like a lot of questions from you guys, but I wanted to start off with one question which is actually formulated by Rich. I think it's a great question, and here's the question, which is maybe primarily to the artists, but maybe to everyone. Rich says, logic plays a huge role in mathematics, and certain things, though possibly beautiful, are just sort of inadmissible because they turn out to be false or fallacious. Are there similar constraints in art? Anyone? So to me the question is basically, is it enough to be beautiful if it's art? Or are there other criteria by which you judge whether something that you make is fully realized as an artwork, I guess? Yeah.
Well, that's a loaded question. Beauty, I'm not sure that most artists would say that beauty is the only criterion these days. There's also, and maybe beauty as we think of it classically is really fundamentally a manifestation of the ability to make you think, the ability to make you reach beyond your normal experience. Because what one person thinks of as beautiful is not necessarily what another person thinks of as beautiful. But the spirit behind the making of an artwork might be to draw out a sense of wonder or a sense of curiosity or simply to catch your attention somehow. And so to me, that is perhaps the only constraint that I would formulate for art, which in some sense is also true of math.
So for me, it's also the idea is really important, which I guess in math, idea is also very important. But idea could be as simple as, oh, this light is really beautiful on that surface. That could be your idea, but it could be other things as well. It could be a system. It could be some kind of intent, an intention of what you're trying to explore. Or it could be an exploration, or it could be a statement, or it could be all of the above. And then, as I think I agree that some people may find it beautiful, some people may find it really ugly, some people find it so ugly that it is beautiful, but that's kind of secondary, right? So.
But I think also is that you have to be surprised by what you see, by what you do. Maybe a little bit amazed. You look at it and you say, oh, wow, okay, so I get it. I got something. And I can work on it, so I think I can develop something with that, because me, at first, I find that is interesting to go forward, to try to explore a little bit further what could happen with that. And maybe the beauty comes after that. And the beauty is not because you look at it. Sometimes also is the people will judge if it's good, if it's beautiful or if it's not beautiful. Sometimes it happens many times that some things that I made, I didn't like it very much, but people look at it and say, oh, it's so beautiful. And at some point, I changed my point of view about that. So, yes, it's a surprise. For me, it's a surprise. It's something that accident, something that you cannot expect.
I want to add just one little thing, is that sometimes beauty is not part of the equation at all. Like, it doesn't have to be beautiful. It may have some other totally thing. Is this not on?
I think it's on.
It's on? No, it's not on.
Maybe give her the other one.
Oh, now it's on. Is it on now? Ah, okay. What I said was that sometimes beauty is not even part of the equation. Like, it's irrelevant completely. It's really just not about that.
I don't feel like I have much to add here, except that I do think that the role of logic in mathematics is overplayed in terms of people's perceptions of how it works. I mean, sure, at the end of the day, you want to write down a proof, but if you start digging into why people study what they study, why they conjecture the things that they conjecture, why they believe things to be true that they haven't yet proved, I think that the logic runs out pretty quickly, and considerations of sort of aesthetics and structure and beauty and those fill in a lot of space that's left behind when you take away the things where you haven't been able to apply logic yet.
Okay, so that was sort of an opening. Wait, is this on? Hello? Okay, so that was sort of an opening question, but then we're going to have the presentations, and then we'll take more questions afterwards. So Werner, you're up. Are you good with it?
Amplification up here, or should I just speak loudly, or? Okay. So thank you all for coming. It's great to see so many people here. Thank you to the organizers for the invitation. Thank you to everyone here at ICERM for putting this wonderful event together. It's great to be here. So my name is Werner Sun. My background, as Rich said, is in experimental particle physics. For about 2 decades, I did research at the Cornell Electron Storage Ring and at the Large Hadron Collider at CERN in Geneva, Switzerland. The Cornell Electron Storage Ring is in Ithaca, New York. One of the things I focused on while I was doing research was the weak nuclear force and the complex unitary matrix of couplings that describes it. Over time, my role at Cornell shifted around, and I'm currently the IT director at the Cornell Laboratory for Accelerator-Based Sciences and Education. And this is the host laboratory for the Cornell Electron Storage Ring. So like many artists and like many scientists and mathematicians, I've always had an artistic side. And for the last several years, I've been making these wall pieces that are basically digital images printed on paper and folded into geometric tessellations and then mounted to board. So you can see here an example, a triptych that I made earlier this year. The central section is what's folded. And then here's a side view where you can see the folds more clearly. And a close-up. So the pattern I've been working with is based on the snub square tiling. It's just called the snub square tiling, which is a pattern of squares and equilateral triangles. Except that here I've replaced the triangles with tetrahedra. And this pattern allows me to start from a square grid, so I'm not wasting any paper in the digital print that I have. And these pyramids get formed just by pinching together two adjacent corners of a square and letting the center pop out. So what this does to the image, it compresses it by a third at the same time as hiding a sixth of it. So my work really sits between 2 dimensions and 3 dimensions, between image and sculpture, between the depicted space of the photograph and the constructed space of the fold. And if you're interested in seeing one of these up, for yourself, I brought a small diptych that's up here in the front. You can stop by afterwards to see it. So there's also an element of recursion in the way I work. So what I typically do is I make a folded piece, I take photographs of it, I use those photographs as the starting point for the next folded piece, and so on and so on. So in fact, this piece that I showed here started out as this photograph. And this photograph shows a folded piece that I previously made, which was itself made from photographs of yet another folded piece. So another way that recursion comes into my work, I sometimes start with these computer-generated fractals generated by this program I wrote in processing. I'll just let this run through. This just implements a simple random branching algorithm. So each point gets a yes or no, do I branch, and in which direction do I branch? And that gives me images like this that I then fold into pieces like this. So here's another example, a photograph of just a piece of folded paper that eventually becomes this diptych here. Half of it is folded. So it's a single image, half of it is folded, half is not. And this piece is part of this exhibition that Rich mentioned. So I'm currently showing at One Liberty Plaza in Lower Manhattan. It's a year-long exhibition, thanks to the Q Art Foundation for that. And it's up through 2020, August 2020. So if you're in the area and you want to take a look, let me know, I can get you in. So this central piece, this large piece in the center here, shows a different kind of fold. So this is the Miura Ori, or herringbone fold, where there is actually no cutting or gluing involved, unlike the other kind of folding that I do. And so if you take a look from up front, you see that the image for this is, again, a folded piece that I had previously made. So my work draws on many different influences. There's geometric abstraction, there's op art, light and space art in the way that I play with perceptual effects, collage in the way that I take images apart and put them back together again, and of course photography, except I'm not using photography as a recording device to depict something, but just as a tool for abstraction, for turning objects into images. Because the main concern that I have, the overriding concern of my work, is the way we see, the mechanics of active seeing, and the subjectivity that's involved there. So to get to the theme of the semester, even though I use a geometric vocabulary, my work does not illustrate specific math concepts. But I would suggest that my process is somewhat mathematical in spirit, because by adding images to folds, I've set up this two-state system of image and sculpture where I can oscillate back and forth between the two in a recursive way. And each step builds on what came before. So in fact, this piece I'm showing here was part of a whole installation based on that idea. of a single image as the starting point for a whole series of pieces. So I would suggest that this way of working is analogous to what a mathematician does, starting with a set of axioms, a set of givens that you just take on faith, and you explore the implications as thoroughly as you can, deriving proofs along the way, deriving theorems that then become starting points for other exploration and other theorems. And in fact, there are precedents for this in 20th century art as well. There's the painter Jasper Johns, who said that his working method is to do something to that, and then do something to that, and so on and so on. And then the conceptual artist Sol LeWitt, who said irrational thoughts should be followed absolutely and logically. And in our case, I would argue that the irrational thoughts are the images that I choose to start with, the axioms that a mathematician chooses to start with. And it's the act of choice that is the irrational thought at the core of any logical sequence, that starts any logical sequence. And I think this goes to what others have been saying as well. So my art is not about math per se, but it's really about systems of knowledge in general as they're applied to the real world, and the tension that always exists between an abstracted description on the one hand, and on the other hand, the actual thing that's being described. Thank you.
Okay.
Okay, thanks. It's wonderful to be here. And I should say that, well, I'm David Dumas, and like Rich was saying, I'm one of the mathematicians who's participating in this semester-long program. I do a lot of mathematical illustration in my work, and I'm interested in the whole spectrum of mathematical illustration, I would say. Everything from mathematical images that are meant primarily to convey ideas to other researchers or to capture the essence of some piece of mathematical research, so more specialized things, to the expository side, where images are meant primarily to convey some idea to non-experts, to share something about mathematics, whether it's research mathematics or classical things that have been understood for 100 years or more, to a wider audience, and allow some of the appreciation of those mathematical objects to be shared more widely. So this is just a collage of a bunch of different visualization projects that I've worked on over time. The racquetball or ping pong game that Rich mentioned is that I don't seem to have a pointer, but it's the center top panel there. And so I thought that for this panel, the best thing I could do is to say, first of all, that I'm really interested in the common features and the differences between the art world and the mathematical illustration world. And to kind of expound on that theme, I thought I would just kind of walk you through one particular visualization project that I've worked on in a way where the final product, I believe, is a rather striking and interesting image. And it's an image of a mathematical object that I have often used in my research and have appreciated for a long time. So to have worked on making an accurate computer picture of this object was very satisfying. And while I don't know if I can say much about the aesthetics of the final image, I do think that it has one of those features that I think I also appreciate about art, that the idea of many levels of meaning, it's both, I think, visually striking to see some of these mathematical images. That's a feature of the best mathematical illustration and something that I aspire to in my own work. But also, if you look more closely, you can start to see features that maybe as a mathematician you've appreciated for a long time, or even if you're not a mathematician and coming at it from just from the standpoint of being interested in what's shown there, you can start to appreciate some of the deep structure and beauty of mathematics through your experience of these images. So I want to tell you about one project that it was a collaboration with Francois Guéréteau that originated in this hand-drawn image by William Thurston from a 1986 paper called Minimal Stretch Maps Between Hyperbolic Surfaces. And so this was a kind of cartoon drawing of a mathematical object called the space of projective measured laminations. And it's very much a schematic drawing. It depicts some object that has very high dimension, but it tries to show the essential features of that object in a kind of low-dimensional analog. And various features of it are labeled. And I was always curious, how accurate is this picture? What does this object really look like? I, for many years, had a mental image of what this object was and used many of its properties in my work, but I couldn't really say in the most direct sense that I had ever seen it. So let me tell you just in a minute or two, what are the basic building blocks that go into this object so that you have a reference point for understanding the image I'll show you in a moment. This is a mathematical object in which every point of it represents a curve on a surface. So here is a genus 2 surface, a 2-hole donut, and a curve is drawn on it in red there. And there are lots of curves on a genus 2 surface. There are simple ones and there are complicated ones. And so these curves that I've just shown you, these three, would be 3 different points in the space. By the way, I should say, when I say curves, they are not allowed to intersect themselves. They have to be simple curves. So having a figure 8 curve like that is not allowed. Okay, so these, the other rule, strange rules apply to this object, is that if you just wobble a curve slightly, it's considered the same thing. I think you would believe me if I said that these were, in some sense, essentially the same curve. They've been slightly modified from one another, but say the curve C or B that I showed before are essentially different. So this space is a space that consists of all the essentially different curves on a surface. Now, I used 3 examples. There are infinitely many different curves that you could look at, but the key idea in this business is that these 3 curves are really 3 points in a larger geometric space. And this space consists of all of the possible curves and even kind of limits of them that form these more complicated pictures. So the big question then is how you arrange these points to get a coherent picture of all the possibilities. And for 3, you could just choose to draw them however you like. But William Thurston's main contribution here was to come up with a way to kind of glue all these points together in a single coherent object. Now, for technical reasons I won't get into, I don't actually intend to show you the genus 2 surface example. Instead, I'm going to show you a simpler kind of surface where it's a sphere with 5 punctures, which, as a parent of young children, I can't help but think of as a onesie. And the kinds of curves that are allowed in that case are curves that split it into I guess a shirt and a pair of pants, something like that, kind of like this A, this B, if you think about it, or even this C. So again, there are infinitely many possibilities, but we don't allow curves that simply go around one of the punctures. So maybe I'll show you an animation now of, I guess I do want to allow this animation to play. Yeah. Of the space of curves in that sense on the 5-punctured sphere. So what you're seeing here is, I think, 300,000 curves. Each one is marked by a sphere. The larger spheres mean shorter curves. So the most prominent features of this image are the very simple curves, like A, B, and C that I showed before. The tiny ones are very long curves. And I think one of the things that immediately stands out about this picture is that it has some sort of hierarchical, some deep structure inside of it, where curves come in many families. They form these strands or sheets that are everywhere in this image. And that corresponds exactly to topological ideas about how surfaces and curves interact with one another and how they're structured. So there's, well, in 5 minutes, I'm not going to tell you a lot about it, but there's a lot of structure that you can see in this image. And I think every time you return to it, it's possible to see even more of the mathematical structure of curves on surfaces if you look closely. Maybe I will just finish by showing you one more view of the same thing. this object is actually in a higher dimensional space. And I showed you an image of it rotating around I guess the z-axis before. And and here's just a quick kind of key to the map. Every one of those spheres represents a curve on the surface. And the examples that I showed before are some of the prominent features in that image. Okay, so I'll just maybe end with a closer view of the same object, where instead of rotating in the view that we see, it's rotating inside of a four-dimensional space and then being projected down to three-dimensional space. So you'll sort of see it turning inside out. And this is a closer view as well, so you'll be able to see more of the fine detail of the image, if it will play. There we go. It's naturally a convex body in four-dimensional space, and what you're seeing here is the a countable dense set on that body projected onto the unit 3 sphere and then stereographically projected into R3. Okay, so I think I'll stop there.
Okay, can you hear me? Okay, so thank you for having me. It's been great watching all the other presentations, and feels a little strange being up here. I am not a mathematician. However, I do deal with space, and but I deal with space from a point of view of illusion. And I do use systems of representation of that space, perspective being, oh, why is this not? I'm just gonna do this. Okay, well, there go on all my notes. But so the thing that painters really do use in terms of, that's at least a little bit of a mathematical space, is grids and perspective. So so I use that to some extent, but actually the most pleasurable thing is breaking the rules and rearranging things and doing basically whatever I feel like doing. So what I'm interested in is in an experience of space, of what it feels like to be in the space. And then I have loose structures imposed on these spaces, and then I break those structures. So if I were to think about an actual immersive three-dimensional space, I would take fragments from other places and integrate them together into something that's completely new. And a lot of times it involves iteration of the same mark, and a lot of times it involves a grid that's kind of loose but then broken. But what I'm really interested in is getting lost in that space. Like, what's it like for the viewer? Like, what's the experience for the viewer in that space? And but at the same time, what is the difference between the texture, and at what point it becomes a kind of depth? And of course, being from a very cold place and living in a very cold place, I think about ice a lot. So reflections and fragments and transparencies and subtleties. So a lot of times I'm interested in what happens if you impose a really rigid structure on it, but then what also happens when you meander through these structures and when you start to unravel these structures, quite literally. So actually, Allison and I did do a collaboration once, and Allison's work is really about grids and structure, and all I wanted to do is take those structures and kind of blow them apart. Yeah, and then I would just like totally destroy them. So, but also, you know, this is probably the closest I come to a mathematical space. Rich, and those of you who are in my class here, will experience this. Rich actually comes to the class and he talks about various mathematical spaces. So, but of course, for me, the question always becomes, what's it like being in that space, and what it's like to kind of cut it apart and rearrange it. So these are some of the donut structures that have then been blown apart and stretched and redone and organized in something that's maybe more pictorial, perhaps, that doesn't actually function like a mathematical space at all. And so again, I'm really interested in this iteration of one mark or a repetition of a motif, but doing it in a very, very organic way. So another thing that's really great when you work with material objects is that these objects or these materials have a quality. So if you paint on wood, for example, you have the wood grain that you can leave that can inform the structure of the space itself. And so again, you know, I kind of keep going back and forth from more pictorial and less pictorial. This is much more pictorial, much more of a landscape, but it still has these kind of iterations and these kinds of repetitions of the triangles in this case. And then, you know, the scale also, these are very large, so the experience of the viewer becomes quite different when you approach something that's maybe 25 feet long. And it's even more different. The relationship of the viewer to the space is yet different if it's really, really large. That's all. Thank you.
My name is Serge. Thank you to be here because we didn't expect that much people for some reason, but anyway, that's fine now. You know, when you are the last one to speak, sometimes it is nice because you see the other ones before you. 1, 2. So you see the all all your colleagues be before you, and I said, okay, so I will try to do better than them, or maybe I will try to look what they do wrong, so I will try to not do it. But now that I have the micro on my hands, I have no idea how it's going to be. So, but anyway, also another thing that I would like to say is to make me comfortable is also I'm an artist, I'm not a mathematician, and as far as I remember at school, especially on my high school year, on mathematics I was so bad. But it's ironic that most of my practice now I use humbly mathematics, geometric shapes, all that stuff. So we're going to start. Okay, so my interest about works is the ambiguity of the perceptions. I like to play with the fact that I blur the things, because the limits of what you see and what you don't see, and so I play a lot with the optical effect or illusion, and I ask also to the viewer to be involved also, because like this one is a drawing that I made, and my question was, okay, so what can I make to be sure that the people confuse him about what they see, what they think to see, or what it is in reality. So that fact is in that point. So I said, okay, so why should I make something that is very obvious that you can see at the first sight, and something that you will see on the second sight and second lecture, in this case here, if you are closer. So here also, but here, yeah, it's obvious that you see two squares. Maybe they hit together, or maybe they try to go away from one to the other. But when you get closer, so you also discover that you have other squares that you don't see maybe at the first time. And those squares are made with embossing the paper. So what you see finally is the shadow of lines, the shadow of the drawing. So I started at that time to play also with the light was very present in my work. After that, I tried to work on a larger scale. So this is a wall drawing that I made. And my question at that time, it was, okay, so a lot of work with squares. So I said, okay, the extension of the square, it could be the grid. It could be also the chest floor. So my question, I said, okay, so if I replace the basic on the chest, so if I replace the black square and open a window, that you will see another space. And in the other space, that you will see something else. So in that case, what I did is all the black squares. So finally, I open it like a window. And what you see behind is another space where I put a fragment of other squares. And so you have the amount of squares, and they are different. So I play also with the to make it different one to the other. And also, if you use a wall, maybe that's natural that you can use another big surfaces. So I took the floor. And here, my first point, it was the tiles. So I saw the tiles on the floor. I said, oh, that's a grid. So after that, I said, okay, so what I can do with that to create another space. So what I did, so I made two other grid, and I just twisted them one to different direction. But when you look at it, you have the feeling that you have two different space, but in one space, it's a little bit confusing. So here it's another drawings that it's an extension of the using of the grid. So that time I asking, okay, what I can do between calculation and hazard. So I said I would like to do a drawing and lose the control of it, or to lose the control of to lose the control of it. So I will have nothing to do with the drawing. The drawing will become by a system. So what I did is behind, you don't see it, but behind. So I draw a grid, and each point of connection, so I put a number. So that number, so I write down on a little paper, I put in a bag, and after that I pick up a numbers. So I said after that, I said, okay, so that number will be at the order. I will make the drawing by that order. So if 7, 10, or whatever. So, but I respect the picking of the numbers. So you have the surprise at the end of what it's going to look like. On this one, I have 4 grid, but different size also, because I want to make it a little bit more dynamic. So you have a detail of it. So at the same time, that's funny because it's look messy, but at the same time, you feel that some organization in it. Another one, more drastic, but 1 grid and 7 number. Here I did the same pattern, but more complicated, using the space, using some object like a pedestal, but in the space. So after the line, so I thought that would be nice to try something else with more organic stuff. So I decided to do work with threads, but make a loops with them, put it through the paper, and make a kind of composition, but more organic. But at the same time, I look at it and I say, oh yes, but you have the shadows of the loops. And also, I decided to put some graphite stuff, so it's very confusing because you can ask, okay, what is the loop, what is the shadow, and what is the graphite? Here it's a video. Here is a video that I made afterward is with black light. So the video is about threads that I light with black light. I take a lot of picture of it, and I made an animation, stop motion animation with that, with some effect. And when I presented there, so I light the room with black light. I put some threads, fluorescent, and I put some object who remind some event inside the video. And this is the work that this is the final, what I'm working now is it's about the same thing of the other video, but here is a photograph that I took, many photographs, and is about how the light work on different surfaces, so how they create, so depth, shadows, highlight, and volume. And so I work with papers, so I made a little assemblage of papers, so I did a very close shot of it, and after that I made a video with that, so we'll finish with it, if you don't mind. It's a little video, 2 minutes, with sound. So with the same images, so I made a video that you have layerings and everything change very subtly. How do you? No, it works. But it's very slow. The rhythm is very slow. So, and the scale is very large also. It could be like the wall is here. So the fact is that you are inside, so you come in a kind of environment, and with the sound you are surrounded by all that atmosphere, and you see the way that I use it also, it's a panoramic view. It could be a kind of landscape, but a fiction landscape. So, and where is the color change, where the all move, but very slowly. So it's kind of a little bit Zen, or should I say maybe invited for contemplation. Oh yeah, full screen would be nice. That's better, yeah. But the sound, no. Well, if we don't. So this is the other sound, but the sound also is experimental. It's not. It's a selection of sound that we transform, that we work, and that we synchronize with the image sometimes, and sometimes the sound also announce a little bit, give you some expectation, anticipation of maybe what's coming after. So you have to imagine it in a very close place. You have all the wall, you have this, and you just sit.
Okay, so guess we'll open it up to questions if anyone has them. So I was curious about, I mean, one common theme seems to be experiment. I mean, which we're at the Institute for Computational Experimental Research in Mathematics. So, I mean, for the artist, like what percentage of it would you say is intention and what percent experiment, sort of, when you're...
One, two. It's okay? Yeah, but it's a mix of both. I don't have necessarily a pattern, you know, so it goes as I said previously, I like to play with hazard, I like to play with accident, and so my work is a little bit lead by that kind of thing. But when I find a path or something like that, now I organize something about that. And now I developed my system, and I said, okay, this is the way that I'm going to do that. This is the way, like I did with the pick a number, or play with a chessboard, or play with the space, or play with the people also. Okay, so you can see something when you are far, or you can see something when you are close. And I do it the same way that I like to see something. So so I always do that my stuff that way. So at first, this is how I like to see something, and after that I try to figure it out. How can I present that stuff, or change, or show it for someone else?
I think for me, it's also a mix of both. There's a little bit of intention, then a lot of discovery, then back to intention, then back to discovery, and kind of back and forth.
Yeah, I would agree with that. I think if you're experimenting all along the way. You might start with an idea, but once you take that idea a little farther, you might discover you need to change course a little bit, and you're always reevaluating where you are and where you want to be, and you're always paying attention. I think if you know where you're going, it ceases to be a work of art. It ceases to be a work of math. I think what unites the way mathematicians, artists, scientists approach their work is that they don't know where they're going, and yet you're going there anyway. And talk about irrational. That's the most irrational thing you can do. And so experimentation to me is synonymous with being irrational.
I was just wondering what draws each of you to your individual practice and exploration. Like, what draws you to the different, I don't know, the different elements you're exploring, the different things you're exploring in your practice, if you know.
I think for me, having moved from a different country and had to adapt to surroundings, I think my work is about getting lost, essentially, and kind of meandering, and so I want it's working? So I want the viewer kind of do that with me. I want to take them on a trip, on an adventure, and have them, like, drop them off and have them figure it out.
Me, I think I'd like to be lost, but I'd like to be also organized. It's really a mix of both. And when I started something, it's very messy. So afterward, so now I said, okay, so I want to go. So I want to experiment that thing. So okay, that sounds interesting. So okay, so now how am I gonna do this? So yeah, so I made a lot of experimentation, a lot of sketches, because I want to see if my idea makes sense. And after that, okay, so when I found what I want to do, I said, okay, so I go.
I think two things. First, I assume that most math papers have somewhere between 0 and 1 readers, and so they're often studying these intricate, detailed, beautiful objects with so much, many layers of meaning and so much built into them, and a lot of work distilled into understanding their properties, and it's sort of closed off and difficult to access. So I've always been attracted to the idea of trying to make images that, just by virtue of people having such good geometry coprocessors built into their eyes, that they could be appreciated. And I realized, I was contemplating just now that I probably speak about mathematical illustrations in kind of grandiose terms, but that's reflecting what I think mathematical illustration can aspire to, rather than maybe what it achieves or what I can achieve. And the other thing is, I think that there's the possibility for accurate images of mathematical objects to actually accelerate the understanding of those objects, even by experts who know them well. That you can see things that maybe you didn't appreciate before you had an accurate image. Or you could, another thing is that it could accelerate your understanding. You might be able to determine what it should look like by thinking about the rules that are in place, but if you have an image that you can just call to mind, you don't have to think about those rules. You can call to mind the image. And often having one really good example or one really good image that you can call to mind quickly is a way to accelerate research progress. So I think those are the two things that came to mind.
I guess for me, I've always had a controlling streak, and so I really crave order. I hate randomness. I hate change. And, geometry is such a clean field. You have a very small number of axioms that just gives birth to a whole world of knowledge. of facts, of theorems, of axioms, of lemmas, of knowledge about the world, and it changes the way you see the world. And so I'm drawn to this geometric vocabulary for that reason. I've always played around with geometry, with folding, even as a kid, and I kind of forgot about that for a long time until about 10 years ago, and I started working with these images, and I said, what can I do with these images in real three-dimensional space? And then it just came to me to put two and two together, and I just started folding them. But by doing that, I came to realize what I was really interested in is the way images transform themselves when you get your hands on them, when you manipulate them to create something new. So, you know, it's kind of an accident that I started working with images. It's an accident that I was drawn to geometry, but if you can, the meaning of the combination, the meaning of what you're doing, it's in there somewhere, and it's there for you to discover. And I think if you just follow your intuition, you'll eventually figure out why you're doing what you're doing.
All right. Hello. Okay. So, what's the importance of like scale in your work, and how do you like go about choosing a scale for an artwork when starting?
I think for me, there are different considerations. The first image I showed you was about 6 by 6 inches big, so it's very small. And then the later ones that I showed you were quite large. So I think in the small work, you want to fit, you kind of want to cram a whole world into this little thing that kind of expands as you look at it. And then the larger pieces, I would like to experience more while moving. So the experience is less intimate, but it's also much more meandering and much more of an adventure in a way.
Me too, when I started, it's pretty small. So as I said before, I made a lot of sketches, something like that, because I have an ID, but I have to see my ID. So I made a lot of sketches, and so okay, I say, so I will try maybe a little bit bigger, until the time that I said, okay, maybe I will try something in a very large scale. But it come gradually. And afterward, maybe if I do one or two pieces, after that I will maybe directly think about a big scale. Like the video, it was that. I didn't think 1 minute that it's going to be small. I said that will be large, that will be take the whole wall, and the people will be totally surrounded by that. But a little drawing, maybe you don't need that much. Well, I don't know, because I do it that way, and it's nice also to see something close, and sometimes to get back, to step back and see something big.
I think scale plays a huge role in how you experience a work. If you need to lean into something to see the tiny detail, if it's something small and you need to lean in to see it, the way it affects your posture, the way it fills your visual field is completely different if something is the size of yourself. You relate to it differently. You're, just somatically. I would love to work larger and larger. I'm kind of limited by the amount of space that I have. I just work on my kitchen table, and so I have 3 by 5 space to work with. And so my strategy for going large has been to work in sections. So that's why I'm doing more diptychs and triptychs, so I can work on each section independently and yet have the put things together in the end. One thing that often happens, and I hear this a lot from artists in general, once you go big, it's very hard to go small again. So there is definitely something addictive and alluring about large work, the spectacle of it and the way it can draw a person in.
Okay, so this has been really great. We're almost out of time. We have time for one more question, and then we should go.
Thank you. Hi. I was wondering what you believe the relationship between process and emotion to be. Do they inhibit each other, move each other along, or is it more complicated? And if so, what is that complicated nature? Emotion and process, yeah.
I need to think about that for a moment.
Yeah, I think we all need to think about that. Where do I get to start?
I'm gonna give it a shot. Okay, so I think my work is very intuitive. So I would like the viewer to have some emotion as they are in the image or as they interact with the image, but I don't necessarily define that emotion when I'm working. So I guess I don't think it's a I don't think I can put a quantity on it, but in my work, yes, it does make a difference. I think because my work is really organic and because it's so related to the mark, then it is very much intertwined somehow, but I don't actually know how.
Yes, I think it's a mix of both. Because you have your attention, you do something, and it has to start with you at first, I think. You have to be, as I said before, you have to be impressed yourself by what happens in front of you. And you say, oh, yes, so, and this is an emotion, because the emotion, that the surprise you have, the fact that you like it, it's an emotion. And you play with that in the practical way. After that, you have to test what is all about, and which material I will take, and which we thought about scale before. So it could be anything. Yes, but I think it's not defined one to the other. It's randomly, that's a kind of a tangle between both of them.
But I think a kiss of death is when somebody is totally indifferent to your work. So, I think I speak for all of us that we all want a response, right? Mm-hmm. But what that is, I don't define that.
Yeah, I think Masha and Serge said it well. Working abstractly, it's very difficult to quantify, to define the emotion that you're actually trying to evoke. But for me, the emotion is in the making. I mean, this is basically what you're saying. It's in the making. It's in the pleasure that you take in seeing something come to life by your own hand. And at the end of the day, that is why I'm making work. And I think of the art object itself just as the artifact of the process, the thing the viewer can respond to, and hopefully respond to it in the same way that I felt when I was making it. But one never knows, and that is just a hope.
The only thing that I can think to say on this point is that mathematical research certainly has an emotional component that people seldom talk about. That, I mean, there are these huge, difficult problems that people spend years thinking about and make no progress on. I mean, in fact, if you take on some big unsolved problem, the chances are that you'll be a shipwreck on those shores, and no matter how hard you try. I think it would be really interesting if some element of that that struggled, and also the feeling that for many mathematical researchers, myself included, we have this feeling of inevitability about what we think about, that we're drawn into it so strongly that it would be difficult to stop, say, even if the grant money were to stop flowing. And that, that sense of inevitability and the struggle and the long odds would be interesting to be able to convey in some way, though I certainly don't know how to do it.
Okay, I should stop, and also let's all thank the panelists and the moderators one last time. So before I let you loose on the hors d'oeuvres outside and more conversations out there, let me say that there will be our fourth panel will be the Monday after next, so 2 weeks from today at 6 p.m. And there'll be a little reception beforehand. And also, many of the participants and the artists in the panels have artwork on display, not just here, but by next Friday, October 18th, up the hill at the Granoff Center in the Atrium Gallery. So I encourage you to head up there. It will be on display for about 2 months, actually more like a month. So anyway, thank you again for coming, and please continue the conversations outside.